A very good day to our lecturer, Madam Haslina. Today in our video, we would like to present our group assignment, which is the case study 7.2. So I will present the question number 1. Okay. For question number 1, we need to develop a multiple equation using the unemployment rate and average monthly temperature to predict the emergency road service call. For the first step, we need to identify the dependents and independent variables. So, according to our question, we can find that the dependent variables is the emergency route service call, and the independent variables is the unemployment rate and the monthly temperature. In this assignment, we will be using the SPSS to analyze our data. So after all of the analyzing, we get the coefficient table. So the next step, we are using the coefficient table to construct our equation. The formula for the equation is y hat equal to b naught plus b1x1 plus b2x2. So we can get the value of the b naught and b1 b2 in the coefficient table. So this is our b naught 26547.282, and the value of b1 is negative 123.858, and the b2 is 212.958. In this value, we can see that the positive relationship of the b node and the b2, and the negative relationship of the b1. After we get all of the value, so we can substitute the data into the equation, which is y hat equal to 26547.282 minus 123.858 monthly temperature, which is our x1, plus 212.958 employment rate. So this is our equation. The regression equation explains 0.5279% of the variation in emergency service call. The standard error of the estimate is 1281.2866 emergency service call. This value is measure of the emergency service call differ from the fitted value.
For the question 2, create a new temperature variable and relate it to emergency route service. Remember that temperature is a relative scale and that the selection of the 0 point is arbitrary. If vehicles are designed to operate best at 65 degrees Fahrenheit, then every degree above or below 65 degrees should make vehicle operate less favorably. To accomplish a transformation of the temperature, data that simulate this effect begin by subtracting 65 from the average monthly temperature value. This transition 0 to 65 degrees Fahrenheit should absolute value of this new temperature variable be used. So to find the new temperature is equal to temperature minus to 65. The 65 is the best at 65 degrees Fahrenheit. Yeah, the question mentioned. So this is the new temperature. The new temperature 0 is the best operation best. 1 operate less reliably. So 0 is the operation best because the vehicle is 65 degrees Fahrenheit.
Now I would like to present question number 3. Okay, question number 3 is transform the new average temperature variable so it is linearly related to service call. X is the dummy variable for temperature and Y is the root service call. Okay, dummy variable take only two values, either 0 or 1. 0 is 65 Celsius, which is the best operation, and the 1 is more or less than 65 Celsius, is which vehicle operation less reliably. And this is our equation. Okay, B naught is 21126 and the B1 X1 is a 303.143 new temperature. Okay, we can get the value from the coefficient table, and this one is a constant 21126 is a B naught, and this one is a 303143 is a new temperature, and the dependent variable called is the Y. And this is the relation between two of them. Okay, of the first one is when vehicle operate best, the emergency call is about 21126, and when vehicle operate less, then emergency call is okay, and the answer is 21429.143. Okay, thank you.
So my name is Ng Ji Chuan and I will present the question 4. So for the question 4 is create a new unemployment rate variable and relate it to emergency road service and give unemployment a lagged effect on emergency road service by using unemployment rate for the month, which is 3 months prior to the current month and 11 months prior to the current month. So this is the table for the 3-month lagged rate unemployment rate and the 11-month lagged unemployment rate. So this is 1, 2, 3 and this is 1 until 11. So this is the table for the 3-month and 11-month. So for the correlation is negative 0.206, which is the yellow color. I highlight this one already. So the relationship between the 3-month lagged unemployment rate and the core is not significant. This is because the p-value is bigger than 0.05, which is not significant. So for the 11-month lagged rate, the correlation is 0.708, the yellow color one. So the relationship between the 11-month lagged unemployment rate and the core is significant. This is because the p-value is less than 0.05. So this is significant. So for the best model for the prediction is 11-month lagged unemployment rate. Thank you.
For question 5, is develop a multiple regression equation using the transform average temperature variable create in step 3 and the largest variable create in step 4. This is a good model. Have any of the underlying assumptions be violated. For the equation we got from the SPSS is over here, and then we will do the F test. Since the p-value is smaller than 0.05, so enough evidence to reject H none. Since the new temperature and 11 months larger unemployed rates will affect to the emergency road service call, so this model is good. For the t-test, new temperature, since p-values is 0.869, since the p-value is greater than 0.05, so we reject H none. Since the new temperature is not significant effect from the emergency roll call service, though the model is not good since there are one dependence variable are not significant. Regarding from the questions, they have 4 assumptions for analysis resident. The first is underlying the relation is linear, the error is independent, constant, variance, and normal distribution. So from here we will do the scatter plot to show that the resident is constant and dependent. So from here we see the scatter plot show that the plot is between -3 and 3. So for the PP plot, we see that all plots is nearly from the fitted line. So we can conclude that this is assumption is admit.